वेलकम बैक टू Acme Classes Simply Science, वन स्टॉप चैनल जहां पे आपकी सारी साइंस रिलेटेड इश्यूज फॉर क्लासेस 9th and 10th को रिजॉल्व किया जाएगा। Before I start the video today, may please be noted कि यहाँ ओवर सिंप्लीफिकेशन ऑफ कॉन्सेप्ट्स है। ये क्लास 9th and 10th के कॉन्टेक्स्ट के लिए है, नॉट फॉर 11th and 12th। In this part 2 in the series of 4 videos, today we will discuss about the Ohm's law and the concept of resistance. So Ohm's law states that at a constant temperature, current through a conductor between 2 points is directly proportional to the potential difference across the 2 points. Now that means current is proportional to potential difference. In class 10th, we say V is proportional to I, but potential difference does not depend upon current, it is the other way around. Current depends upon potential difference. So this is oversimplification of the concept. Now if V is proportional to I, we can write V upon I, and if we have to put equality instead of proportionality, we have to put a constant. Now as per Ohm's law, this constant is nothing but R, in other words resistance. So as per the Ohm's law, V is equal to I into R, and V upon I is a constant ratio. It never changes for a specific conductor because R is a constant. Now what is the concept of R? Let us understand in greater detail in this video and the next. To understand the concept of resistance, let us take these 3 cases A, B and C. These are 3 different roads with a lot of traffic on it. The arrows be representative of vehicles or cars. Our car is the yellow car and the other people's cars are blue cars. So now, in which scenario 1, 2 and 3 do you think it is easiest for the yellow car to go through or pass through the crowd? You can take your time, you can pause the video and then think about it. Hoping you have paused the video and thought about it, let's proceed on to the next. So clearly, it is much more difficult for this yellow car to pass through in scenario 1, slightly lesser difficult to pass through in scenario B, and least difficult is when in case of scenario 3, where there is hardly any traffic on the road. So wherein the obstructions are more. Case 1, the obstructions are the maximum, then comes case 2, and then comes case 3, where the obstructions are the least. And by the term by obstruction, I might add the word resistance. Where is the obstruction or resistance the maximum? Case A, obstruction or resistance is the maximum in case A, lesser in case B, and least in case C. Highest resistance is in case 1, lowest resistance is in case 3. If that concept is understood, let us look how electrons flow in a piece of conducting wire. So if electrons are not connected to a battery or source of electric current or potential difference, they move around or vibrate in any specific direction. They are not moving anywhere. For them to move anywhere, we have to connect them to a potential difference or a battery. Now if you connect them to a battery, now there exists a potential difference between points B and D because of the presence of the battery. Now flow of current can be a flow of positive charges or negative charges. If it's considered to be a flow of negative charges, it flows from the negative terminal to the positive terminal. And if it's considered as a flow of positive charges, the current will be shown as being flowing from positive terminal to the negative terminal. In physics, the flow of current is treated as the flow of positive charges as per conventional science. So, flow of current will be shown to be flowing from anode to cathode. From anode being the higher potential, cathode being the lower potential. If we consider charges as the flow of negative charges, then the negative charges will flow from negative to positive, the negative charge being the higher electric potential and positive charge being the lower electric potential. But like I said before, in conventional physics, the flow of current is shown as the flow of positive charges, though it does not matter which one you show. In diagrams, however, it is to be shown as the flow of positive charges from anode to cathode. Now, these are the 2 different directions in which electrons can possibly flow. Like the car example before, as shown before, when electrons have to move from point A to B, they basically encounter a lot of other electrons. If positive charges are flowing from point B to D, they will encounter a lot of other positive charges, thereby creating obstructions or resistance. This is the concept of resistance. When charges flow either positive or negative through a conductor, they get obstructed by each other. This obstruction is known as resistance. So like I said, positive charges flow from anode to cathode. That means from higher electric potential to lower electric potential. Negative charges flow from cathode to anode, that means from higher electric potential to lower electric potential. Which will be higher, which will be lower, depends on the nature of the charge. So what can we say? We can say that just like in the presence of traffic hinders the motion of the yellow car. So in that example, if there was a greater degree of traffic on the road, the yellow car motion got hindered. Similarly, collisions with other electrons as well as ions and atoms inside the conductor hinder the movement or the path of electrons or positive charges, as the case may be, then that concept is known as resistance. So resistance can be defined as the obstruction, the hindrance offered to the flow of current by a conductor, and it is measured in ohms. And the symbol for ohms is omega, the Greek alphabet. With this, we come to the end of this video, which deals with what is the concept of resistance. In the next video, we'll discuss in great detail the factors affecting resistance and resistivity. Hope you liked your video, and if you did, please do not forget to like, subscribe, share, comment and press the bell icon. Thank you and have a nice day.